As Industry 3.0 becomes Industry 4.0, enterprises are having to deal with an entirely new level of data volume, variety, and velocity. With IoT devices proliferating globally and expected to triple to more than 25 billion by the year 2030, enterprises are having to deal with an entirely new level of data volume. There's never been a better or more vital time for enterprises to invest in IoT infrastructure. Thanks to 5G, industrial devices can now communicate with each other at latencies once considered impossible. With the human element of action-taking now removed and replaced by machines, latency SLAs have shrunk from seconds to milliseconds, and this data speed acceleration is making it hard for traditional data platforms to keep up. Streaming real-time data, coming at massive volume and velocity, needs to be handled as quickly as possible to be able to make decisions before the damage is done. Thankfully, there's a modern data platform designed to handle the unprecedented challenges presented by 5G, IoT, edge computing, machine-to-machine communications, and other new technologies such as digital twins. Volt Active Data is the only platform purpose-built to handle the demands of modern industrial IoT applications. Combining the ability to make intelligent, accurate decisions at ultra-low latencies with advanced machine learning, ACID compliance, intelligent queuing at scale, and a simplified edge-ready architectural footprint. Our platform has already been battle-tested in multiple live industrial deployments around the world. The Volt Active Data Platform was designed to support the most complex and challenging IIoT use cases and deployments, including business process automation, preventative maintenance, authentication and authorization, and asset tracking. Volt Active Data, the only data platform purpose-built for enterprise-grade industrial IoT applications in the age of 5G and edge computing. Get started with Volt Active Data today.
The world generates 147 zettabytes of data per day. To stay competitive, businesses need to act on this data in milliseconds before it loses value. As your data's shelf life decreases, so does your chance to optimize its value. Volt Active Data was designed to enable companies to act on data in real time, without compromising on scale, latency, consistency, accuracy, or resiliency. Volt, the only no-compromise data platform built to handle the real-time demands of modern applications.
Good morning, everyone. Thank you for joining us and a warm welcome to Volt Active Data webinar on the Hyperscale Data Platform. My name is Indraban Tiwari and I'm part of Volt marketing team. And also I'll be your host for this webinar today. Volt Active Data is a modern data platform combining stream processing, caching, complex processing on transactions. Volt powers application to process data from ingest to decision in under 200 milliseconds, which means the decisioning part happens in under 10 milliseconds without compromising on data accuracy. This webinar will delve into how Volt Active Data can simplify architecture for hyperscaling applications that can handle massive traffic loads without compromising on performance or security. To discuss this further and add more detail on this, we have a great speakers today. But before I hand it over to our speaker, I would like to inform you all that if you have any questions during the session, you can feed the same in Q&A section that you can see on your Zoom screen. Also, at the end of the session, we will run a live raffle. People who stays till the end will be eligible for this. Once you see your name on the screen, please mark your presence by saying, yes, I am there in a Q&A sections. I would also like to introduce you all to the team. So we have Caroline Long. She is a global marketing director with Volt. And we also have Viplab Banerjee. He is a pre-sales lead. You can connect with the team over the email that you see on your screen, or you can also connect with them on LinkedIn or any other social media platforms. Now, I would like to invite our speaker, Mr. Fahad Khan, who is India's sales director, to take it forward. Over to Fahad.
Hi, thank you, Nirvan. Hi, everyone. Good morning. Thanks for joining in and taking out your time. I hope you can see my screen.
Yes, Fahad.
Yeah, right. All right. Thanks, everyone. Thanks, Nirvan, for introduction. My name is Fahad Khan. I lead the sales for Volt Active Data across India and APAC. I come from data and analytics background. That's where last 15 years I've been through the journey of where reporting was done once in a week, once in a quarter to we moved it to alternate day, end of day, hourly, minutely, hourly, every 30 minutes, 5 minutes. And I went through a lot of projects evolving analytics and insights or data insights or helping decision making and brought that latency as close as possible, right? So I went through the journey of standard, or you have your transactional system, you process your transactions, move it to a data warehouse, bring a BI solution, spend all the integrations, build data pipelines. So all this worked and has been working, right? And it will definitely work. But I think what I realized over the last 3-4 years is the decisioning is becoming so close and so low latency that all of these architectures are not able to keep up the scalability factors that we are bringing, right? Transactions are just no more transactions. Transactions are interactions with your end customers or your end user and your gateway to act on it, either to prevent or utilize that opportunity. So that's where I bumped into Volt Active Data a year back and realized what Volt is doing across the board. So Volt has been there for quite some time, has really great customers, and I've joined them, right? So you all have seen this. After pandemic, I think it is digital everywhere, right? I know it was the most hard time and it was the most troublesome time for a lot of us, but that drove a digital adoption that was never seen before, right? Digital payments became very obvious. Global internet penetration has grown, right? India alone, the rural sector has grown more than 50% with digitization. Social media and communication platforms have grown. They're just no more messaging platform, right? They're transactional platforms now. You can pay, you can buy, you can transact on social media. Internet of Things has grown. It is just no more a sensor that is sending you a reading. It is more controlling how things are around you work, right? Be it connected cars, be it lighting systems, be it smart meters, smart cities, traffic light management. So Internet of Things has also grown. Digital collaboration has grown. We all have now got used to work from home. So that has given a tremendous pressure for how you use your digital use cases, right? Or how you connect with people, how you work, how you transact with people. Health and telemedicine has also grown. Now we use Fitbits, we use, like till now we were using a wristband. Now I'm very sure you would have heard of the ring that's coming that can measure a lot of health factors and give you analysis on it, right? It can be health saver or life saver in some scenarios where it could give you early warnings of any critical emergencies. Entertainment has changed, right? It is no more TV that is a dish TV that's giving you entertainment. It's streaming solutions, it's mobile applications. And AI has suddenly taken by the storm and trying to address or optimize all of these things. Now, whatever digitization or factor that we have seen, it is always growing with the end user. And that end user concurrency is rapidly growing, right? You take any of these examples of digitization, the concurrency has grown, the speed that people expect things to work has kind of reduced. They want low latency. They want security, which is becoming the most prime challenge for a lot of digitization, right? Ability to prevent rather than identifying fraud, that is becoming a very big factor, right? So if you see scalability is taking a hit, a lot of architectures that were historically there are now starting to fail. And that's why you're seeing a lot of these applications and solutions having outages, having service degradation, right? People complaining about not being able to do the right things. And while this digital adoption has become a very critical factor of our life, then all the enterprises have to address these 4 or 5 critical challenges. Now, Volt Active Data was built on the same thought process. Dr. Mike Stonebraker is the founder of Vertica Postgres Ingress. He's a professor in MIT, and he envisaged the requirement to process transactions as streaming and ability to make decisions on those transactions within few seconds to address adversaries or identifying opportunities is why he built Volt Active Data. So Volt has been adopted by a lot of enterprises globally. The Amdocs, Kyvera, I2I, Flytext. Amdocs has built a billing solution, the BSS for telecom. So it has been used by a lot of telecom operators for their per second billing. So if you're using a mobile phone, you know how the per second, the prepaid works, right? So you have a balance, it has to get aggregated. Now Amdocs is using Volt as the underlying solution. Similarly, Flytext does a lot of hyper-personalized offers for telecom subscribers, right? Now that offers, earlier they had a conversion of 5 to 10%. Now it has grown 300 times to 30 to 40% conversion ratios. Now that's a massive number for any marketing or any offer-based like solution that you would see in the market. Similarly, Unity and Dream11 are using Volt for their gaming use cases, right? So Dream11 is our largest customer that is using Volt for their fantasy sports game, where they enable like 15 million concurrent users to select slots and join them. And all that happens within few milliseconds. Now, transaction processing has grown. Historically, like I said, it was transactions generated, stored, then you move it to your data warehouse, then you run your analytical BI solutions or run your AI ML queries. Now, this has evolved structurally, but it still carries the same ethos of, okay, either it is transactions or events, you stream them. So you have a streaming solution that can move your data. Then you have a caching solution that can cache your data. That is, most of the times nowadays, now that you're seeing is NoSQL caching, right? Because it is faster, you can read faster, you can query, you can store data faster and move it out. And for metadata, because it is NoSQL caching, you end up having a RDBMS database. Once you have the data, then you want to process it. So you move it to a processing layer where you apply your ML logics, where you apply your, build your models, create structures, right? And then you use it for your downstream applications. Now, like I said, it definitely has evolved what legacy was, but it still has those multi-hop scenarios where your transaction or your event, the moment it is generated, has to move through multiple layers to even get to detecting or measuring anything. Now, this obviously creates baked-in latencies because it's multi-hop, data moves, inconsistent view of data. If there are so many different systems that are processing your data, and any of your system fails, or any of your system data does not move at the right time, then you definitely will have inconsistent view of data. I have seen this, right, in a lot of applications and solutions where you move from one screen to a different screen, the data does not match. Bloated footprint of hardware, right? And because of multiple systems, compromised failure handling, and all this kind of stresses it out the money part of it, right? Increasing the TCO. That is where Volt Active Data comes as a unified data platform or a transactional unified data platform that can manage streaming end-to-end, can cache data in a standard RDBMS. You don't need a separate NoSQL or a RDBMS. You can have relational data cached in memory, and you can process complex logics or business rules through procedures or the materialized views that we have built in. You can bring your ML algorithm and run within Volt. So it is not batching, it is not micro batching. Every transaction and event that comes into Volt can be subjected to a lot of policies, can be subjected to an algorithm, and a decision can be taken within 10 milliseconds. And all of these things end to end, from the time the data is, or the event or the transaction is generated, to identifying, detecting, and deciding, can happen within 10 milliseconds. And because we are a full-blown Kafka protocol, you can stream it to your downstream applications without a third-party solution. So Volt can become that unified layer for your end applications to your processing and decisioning platforms, and make your users experience the lowest latency and absolute seamless interface. So Vault can help you ingest a large millions of records, store them in relational cache, aggregate, measure, detect, and help you decide and act on it. And all of these things can, while they are happening separately, but because they're happening in one platform without multiple hops, you can address it under 10 to 20 milliseconds. From there, you're not making your applications just transactional solution, but you're making them smart, continuous intelligence applications that can decide and act immediately, right? That opens up a lot of use cases for you. Vault can be deployed on cloud. And here's the best part, right? Whatever I spoke to you can be done on a small edge. And I'm talking about the edge as small as an ARM processor. Now the question is, okay, where do we use it? So edge was kind of brought into the market like maybe a decade ago, but it kind of eventually ran into challenges because how do you bring the complex processing to the edge? And that is where, because most of the architectures were using 3 to 4 layers or 3 to 4 different systems, they never could put it on edge. And that is where Vault is coming in. In the following slides, I'm going to talk about certain use cases where I'll show you how innovatively we are using edge and how edge can simplify data processing. Currently, most of the transactions are, let's say, IoT data sets, right? Everything is getting streamed to a centralized system that is putting pressure on network, on the data storage, and data processing. Most of the IoT data, which is time series data, you need it to identify anomalies and threats, but you don't have to store that for petabytes of storage, right? That is where edge comes into a picture. So Vault is built for critical workloads. It can support massive scale. It can help you run intelligent decisions in real time. It supports absolute accuracy and consistency and the reliability that it brings to the table. That is why you're seeing our customers that you saw are using Vault for the most critical use cases that you could build on. Like Vault is a distributed mechanism. The reason I wanted to bring is most of the times the question that I'm getting asked is, okay, you claim to do X, Y, Z, but what is the underlying part of it, right? So half of the time it is disbelief that people bring to me when I talk about Vault. So I thought, let me help you understand, right? We are a grounds up built architecture. We are a distributed architecture. We have how a standard distribution architecture works. Vault has nodes. Each node has the different partitions, and the data is stored within the partitions. And each partition can ingest data, measure, detect, and apply your business rules on top of it, and do continuous aggregation. Now, while we process at a partition wise, that helps us not to lock the data. So we are lockless, latchless, and we never kind of block any transaction, right? And of course, we are highly durable. All this data is stored in memory, cached, but it is also snapshotted onto the disk so that in case of any eventuality, if one node goes down, the other 2 nodes take care. So it's high availability built in. And just in case the entire cluster goes down, you can restore it from the snapshots or the command logs and make sure you lose no data out of it. We support the entire end-to-end Kafka protocol, and that helps us export data into multiple streams and create multiple topics so that people can use those topics and get the data that we process and get the insights that we bring in. Right. So we have helped a lot of enterprises use Vault. Like one of the key, like I said, the use case that low latency is always seen is you use low latencies to either identify adversaries, right, or opportunities. Now, in a digital connected world that I spoke to you about, threat is becoming a very challenging part of it, right? So that is where one of our biggest use case has been threat detection, where Vault sits between the actual transactional system of the banking, credit card banking, and the transaction. So each transaction comes through Vault. Millions of transactions go through per day, and each transaction is subjected to close to 2,000 policies or rules within Vault, and it is highlighted as fraud or legitimate. Now, this happens even before approval. So that means we are preventing fraud before it happens. We have scaled this for 100 million purchases per day, and this fraud detection is happening within 10 milliseconds. Similarly, DDoS attacks have become very obvious, right? And we have helped customers save more than $50,000 to $100,000 per hour by preventing these DDoS attacks. This application enabled the customer to ingest massive IP data into Vault, into data streams. And because of the capability of high-speed ingestion, caching and processing, they were able to detect and stop these DDoS attacks immediately. I spoke to you about the telecom use cases, right? And the edge use cases. So most of the telecom operators don't deploy in a single location. They have redundant locations across the country, across the geography, to make sure the services don't fall back or don't break, right? And that is where we have seen Vault being utilized. The reason is the key capability of Vault of having cross data center replication, which allows you to have clusters deployed in different locations, and Vault internally manages replication between these clusters to help you process, make sure the availability and you stand a chance to not lose the data anytime. The most interesting use case that I wanted to bring in today was about a traffic light management system. So earlier I spoke to you about edge, right? Why edge is important, or what is the edge that is it plays to it, right? So we have deployed a solution in Seoul for traffic light management, where the traffic light junction has a lot of cameras. All those cameras stream data, and the videos captured are converted to events, and events are streamed into Vault. And those events are kind of subjected to an ML algorithm to convert into inferences. Now, the inferences can be school kids, too many school kids, people crossing, accidents, animal crossing. All these inferences are picked up, applied, processed, and within few milliseconds, either the police is contacted, ambulance is contacted, or you kind of put all the traffic lights red so that the people can stop and everything gets right. Now, this use case is kind of growing to be able to process your insights on the traffic light signal on a small ARM processor. And that is where the edge capability of Vault comes in, and we have seen a massive uptake around it. All right. Now, similar use cases can be drawn across any other use case that you're seeing, right? So the digital adoption in the country is growing, and that is where we see the edge capability that has grown, and that is picking up rapidly, ability to process data right where the data is generated. The biggest customer that we have is the fantasy sports, the customer that I spoke to you about, right? So last year it was 9 million concurrent users. This year with the IPL game, we have kind of supported 15 million concurrent users, right? So Vault supports the contest join capability. Before every match, when the toss is played and the captains choose their game, so the contest is open for close to 200 million subscribers that are there on the app. Out of that, all the subscribers kind of apply to join the contest, and each contest, and all those joins have to be serialized and isolated, right? The reason is it is first come, first serve contest. Now, if I and Indaban try to join a contest, even if it is a split second delay, whoever is first needs to get the slot first. And that is exactly where Vault is supporting with the capability of our serialization, right? We bring in 100% full strong asset guarantees that help you manage that serialization and make sure your transactions are absolutely right. that is where we have been supporting it for last 6 to 7 years now, and we are growing it. Hopefully for next year, we are targeting a bigger, higher concurrency. And the last use case that I have is the IoT anomaly detection use case, which is built on basically for any IoT use case that you want. Now, I spoke to you about deploying Volt at an edge, and that is where I am having use cases that a lot of manufacturing plants that have already deployed IoT solutions on cloud are facing challenge because of the latency of the round trip from the manufacturing unit to the cloud. So we are discussing with a lot of enterprises where Volt can sit closer to their PLC machines. The processing can be closer to those IoT sensors, right? The moment the sensors are generating the data is moved into Volt. Volt captures all that data set, process it, and identifies those anomalies within milliseconds. And that can be acted upon rather than having to wait through the network round trip, right? This kind of creates the low latency and enables you to process data faster, act on data faster, solve problems faster, and you don't have to like bloat your cloud cost by pushing a lot of data to your cloud and storing it over there. Locally process it, aggregate it, and send it to the cloud. And whatever anomalies that you detected are already processed. And that is where we are growing rapidly, and we have kind of seen use cases for high, low latency. Just give me a second. Right. So those are the strong use cases that we have seen, and we are working with a lot of enterprises. The reason that we have been able to do it is our capability to process data. One is ingest, second is process, and the strong asset guarantees that I spoke to you about. You can deploy Volt on cloud, on bare metal, on edge, on an ARM processor, on Kubernetes. So Volt is pretty strong on Kubernetes that can help you manage your DevOps and scale down your deployment on cloud, on our bare metal, or in your premise, and build a resilient infrastructure for that. That's what I had for today. I think the more probably I can take some questions and see what we have. So Inderwan, we have any questions?
Yes, thank you, Fahad, for that session. Now we move to the next piece of our session, which is Q&A. But before we move on to our Q&A, I just want to revisit the raffle details. So people who stays with us till the end are the one who will be eligible for a raffle. We are going to run the raffle at the end of the session, which is exactly after this. So please stay tuned with us. And you must have seen there are a couple of questions. There are a few questions which has been asked by the team.
Right. So
sorry.
So what I was telling is I think there were some interesting questions, right? So also a reason why I've not really created a lot of marketing and sleeping slides. And these questions are right and very, very interesting, right? So all storage and compute disintegrated. So like I said, we are a super low latency processing platform. So for us, ability to engage on the transaction the moment is generated, and driving insights within few milliseconds matters, right? So we are an in-memory RDBMS. So our storage is completely in memory, but for durability, we do store the data on disk and use it whenever we want it, right? So what we enable you to do is get to your information or decision within 10 milliseconds. Post that, either you can choose to store it within Volt, or you can push it downstream to your applications. Security of data on rest and while data is in motion. So I think Biplav has answered it. we support TLS encryption and for data in motion and the data in storage. There was some open. So we are a software that we provide, and you can use the software and deploy it on your cloud, on your on-premise deployment. We can connect to any of your transactional systems. We ourselves we are a transactional database, right? You can build your applications, your SaaS products, your solutions on Vault and use Vault as an underlying transactional database. Or you could use Vault as an engine to connect to your ERP or any other your solution to read the data and process it faster for decisions. Yes, we can run on edge Linux devices. Yes, we can run on Linux. We can run on Kubernetes. You could manage your DevOps completely using our Kubernetes operator. All right, I think that those are some strong questions.
Yep.
Any other questions that you want me to answer? Yes.
Yes. So I would like to open the platform for you and for Biplab both. So just wanted to inform others. We will try to answer as many questions as possible because we do have some time. If your question remain unanswered, which means that we're going to revert it back to you over an email, the question that you have asked in Q&A section. So starting with the first question, open for Biplab and for Fahad. How Vault platform ensures zero-day vulnerability and handles from any kind of ransomware or malware attacks to safeguard data?
Yeah. So basically, Vault supports all of this in every point of security, basically. So there are different ways of how you tackle zero-day, right? So it minimizes the attack surface, right? So your primary data is in memory. And most of the attacks for ransomware is where your data is durable with the data that is in test, which is in disk. So you can employ different kind of mechanisms to encrypt your disk data. And while the data is in transit, let's say the data is traveling from your application to your database, right? So those are encrypted over TLS, right? So that is one way of doing it. The other way is, all sorts of role-based access control. So what gives you the mechanism to do user authentication, authorization, all those kind of things. Plus, you can assign specific roles and responsibilities to a particular user to retrieve data or do manipulation with a specific amount of data, right? And we do also provide, let's say, security updates from a industry best practice adoption perspective, and any sort of attacks that the industry discovers. We sort of release the patches for those kind of vulnerabilities it depends upon the type of attack on a zero-day response time basis, right? So those are the kind of things that we employ to kind of mitigate these challenges.
Thank you, Biplab. So Biplab, I would also request if you can come closer to the machine because your volume is a bit low. Next question. For you and for Fahad, any of you can answer.
Okay, I think there's a question around TCO comparison against Databricks and Snowflake, right? So the point is, Databricks and Snowflakes are data warehousing platforms, right, or data lake platforms. They have a different objective altogether, and their objective is to streamline the overall enterprise data, right? And we are part of it. We can integrate or become part of that and enable you to act on your data. Like you can use Databricks to build your ML models, but when transactions are happening, you want to use that ML model, right? Rather than moving the data to Databricks or Snowflake, then running your ML model, how about using Vault as your transactional system? And the moment the transaction is happening, Vault evaluates your transaction, acts on it, and then you push it down to your Databricks for further ML or other processing. So we are kind of a layer before these solutions and help you prevent rather than act. Now, when we sit before any transaction, right? For example, you take any transaction, be it a credit card transaction. I can help you prevent threat, and I can help you find opportunities for hyper-personalization. So when you're mobile, when you're person, like in BFSI, which the use cases that I'm talking to certain banks are, when people log into their mobile phones, I'm sure you all experience that, right? You're given with offers, loans, mutual funds, various things, depending on your profile. Now, the problem that is happening is all these offers are built using data which is historical in nature. Like you would have checked out a loan page probably 2 months back. Now that 2 months data is churned and kind of highlighted that, oh, you are interested in a loan. And next time when you come to the app, you're like, a pop-up comes for a loan or somebody calls you for a loan, right? That is where your frustration builds, that I never asked for a loan. Maybe you'd have asked, you'd have thought about it or checked out it for 2 months. And that is where we are bridging the gap of ability. Like you came to the mobile app now, you checked a loan page now, so you need to get the offer now. And that now needs to be processed within 10 milliseconds. And that is where Bolt comes for hyper personalization. So that is how we are absolutely different from Databricks and Snowflake. And we help you do those things, what you want to do now, right?
Thank you, Fahad. So next question will be, we have AWS with SAP ERP, how it's used and how to deploy your services into existing environment.
So like I said, we can go on AWS, we can go on bare metal, you can deploy on edge Kubernetes. So it is the choice of the customer where you want to deploy Bolt. Now, like I said, it's not about SAP ERP. SAP ERP has its own purpose and built to manage certain aspects. But before SAP ERP or post SAP ERP, where you want to act on data and process the data within milliseconds to identify anomalies and detect threat, that is where we come in. Now you put us on AWS or on-prem along with SAP, that's the choice of the customer.
Perfect. Thank you, Fahad. Next question in line is, how relevant is this for SaaS-based products, as we are building a SaaS product for SaaS product management?
Yeah, so we are a transactional. Good.
Yeah, so from an integration to a SaaS product development perspective, think of using Volt like the backend data processing or transactional data layer perspective. And when you deploy this in a SaaS model for, let's say, different tenants, right? Volt can help you deploy it for your different kind of customers or in a different tenant environment. And Volt's configurations are very minimal, depending upon the type of workload you want to serve in a SaaS-based product, right? If you see, most of our existing customers do offer a SaaS solution, and Volt acts as a primary data store for that. Fahad, if you want to add something to that.
Yeah. See, we are a transactional database. So you would be using, like I said, right? Most of the time, the architecture is you have a streaming solution, you have a caching, then you have a processing. I can be all that one and help you optimize on your SaaS product. So whatever you're building on your SaaS product can perform in milliseconds. So your user experience changes, your data processing kind of becomes the most lowest, and scalability. That's the biggest factor that we are seeing a lot of customers taking other right. It is not about processing data in milliseconds. It is also about scaling to that millions of concurrent users and maintaining that P99 latency, which is under 5 seconds. So our all P99 latencies is 5 milliseconds.
Perfect. Next, I think you have already answered this, but I just wanted to bring it on table again. Can we run on customized edge Linux device? What are the minimal system configuration required?
Yeah, so yeah, we can run on any custom edge devices. In fact, we have done a lot of benchmarks and we do have partnerships with most of the edge device providers. In fact, as a matter of fact, we have done recently a benchmark where we tried to run Volt on edge device like Raspberry Pi, and we were doing pretty good, throughput, about 1 million transactions per second, and the P99th percentile latency was less than 10 milliseconds, right? So yeah, the answer is yes, of course we can do that. And in terms of the minimal configuration, so when we talk about deploying deployments in millicore environments, Volt needs about, let's say, 200 millicores as a bare minimum to start processing, right? In terms of edge deployment. And then of course the other sorts of resources depends upon what kind of data you want to store for what amount of time, and that would decide the amount of RAM footprint and the disk footprint basically.
Perfect. Thank you, Viplab. Next question in line is, does Volt only serialize real-time streaming data, or can it also harmonize real-time and batch data in real-time fashion if required?
Right. So Volt can do both, right? Volt can support batching, and it can and it does processing of the data in a per event basis, which is streaming, right? So that's the answer possibly to this.
Perfect. Next, does Volt analyze on-prem devices such as security cams, access control device, DVR, and web conferencing equipments?
Right. So it depends at the end of the day what you want to do with these devices, the events that are being captured and processed through these devices. What is your target intention with that particular data? Now, if you see Fahad in his webinar mentioned about a use case which we call as a traffic digital twin, right? Now, the event frames or the video frames that are being sent through the cameras that are deployed across different traffic signals, road intersections, etc., are being sent, and those events are being translated from video events to data events. And that's when a decision needs to be taken on the data events, like measuring a distance between two cars, or what is the situation right now on a particular road intersection. Has there been accumulation of a lot of people or students near a school where they are waiting to cross a road? So all these kind of identification and taking the right action for them, whether you want to get the, let's say, the traffic lights from a green to a red, or you want to inform the authorities in case we detect an accident or a collision. Those kind of decisions needs to be done. If you want to do those kind of decisions, then those kind of analysis is what Volt can help you do with any of these devices that we are talking about.
Yes, Biplab, next question in line is, what makes Volt Active Data platform capable of handling massive scaling demand?
Yeah, so Biplab's favorite.
Yeah, I think that's what I think Fahad just took up, that architectural design, right? I think it's our inherent architecture that makes it totally different, right? As Fahad mentioned, our founder is a database pioneer, Dr. Mike Stonebraker, right? He has been designing databases since the time, I think ages now, about 30 years now, right? And the basic, when he was trying to design Volt, he studied what are the underlying bottlenecks in a traditional database that we use, right? There could be things like locking, latching, a lot of data that goes to disk, so your IO is a concern. All of these kind of problems has been mitigated. Now, doing all of these things, apart from doing all of these things, the modern way of how you want to distribute the transactions to handle massive scale is by sharding that particular data. Now, sharding is typically imagined that, I keep a piece of a part of the data in one particular machine and the rest goes to another machine, and I throw in transactions to all the machines so that I can do massive parallel concurrent transactions. But in Volt, the data sharding is not only on a node level or a machine level, but it's also at the CPU core level, right? So we shard the data and map it to per core basis, right? That's what makes the entire design of Volt very different to any comparable traditional database or NoSQL databases of that Volt.
So Biplab, next question in line is, how does Volt Active Data's platform support high performance analytics and decision making?
Right. So I think, as I said, right, Volt is primarily the backend data processing storage, right? Now, when you talk about doing transactions, I want to interact with a storage layer where I want to insert, update, or do basic CRUD operations, right? So Volt does support that. You can interact with Volt in a request response fashion by doing all sorts of CRUD operations. But apart from that, when you want to do real-time analytics, right, you want to understand or pattern match something quickly, detect a fraud, let's say, run through complex logics, every transaction, and analyze. Let's say you want to maintain a counter that, this particular event has occurred how many times in a particular window of, let's say, 30 minutes, right? And then compare it against the last hour. All those kind of analytics could be done all inside Volt, and Volt gives you the facility to write this entire business logic and host it on the database server itself. So it does reduces the network hops between the client and the server and makes it super fast.
Done. I hope Biplab was able to answer that. Next question in line is I'm just reading it out. I believe it should be highly customizable, but how efficient it is when we do the configs/upgrade and need to push to thousands of instances running on the edge IoT devices.
Right.
I think
yeah, Fahad, please go ahead.
No, so basically, see, our orchestration, we are, if you go to the market and talk to a lot of databases, right, everybody is going to talk about Linux, and half of them are going to shy away from Kubernetes. And we are the strongest on Kubernetes. Most of our customers have deployed Volt on Kubernetes. That helps you efficiently orchestrate and manage these deployments. One is orchestration. That could be to nodes, standard bare metal Linux, or to edge devices. And we are working already with a partner to build that orchestration and seamless DevOps for edge orchestration. Second, we have in-service upgrade built into the product. That means you can have zero downtime upgrade across each node. So you don't have to have any downtime to upgrade. So that enables you to manage and customize all of those things, right? And edge devices, we connect to the edge devices to read data, and that's how I think we can work. Biplab, is there anything else you want to add?
No, I think absolutely right. This is what we also emphasize. So yeah, it's all possible, right? And yes, our operator helps to do that to multiple instances deployed across, and we provide all sorts of automation that is needed to do these kind of operations.
Yes. Before that, there was another question around DR. That is also a strong capability that is built into Volt, which is called as cross data center replication. So I spoke to you about a distributed architecture in a cluster where you could have more than 3 nodes and have a high HA built for a cluster. You could set up a DR and enable replication, and Volt internally replicates the data and can manage high availability across different DRs, right? And we can have more than 4 active DRs, right, Biplab?
Yeah, that's what, absolutely. And in terms of latencies, I think our latencies are in single-digit milliseconds. Of course, between any 2 data centers, the latency of the network that connects these 2 data centers, of course, will come into the picture. But from a perspective of the product itself, it can do it in milliseconds.
Yes.
So next question is something to do with regulatory compliance, and seems like it is from financial institution. So
I think, sorry, Indravan. I think Venkat had a question like, is it more like Redis? No, we are far more than Redis. Like I said, Redis focuses only on key value caching. So we do end-to-end Kafka processing. We do RDBMS caching. So you cannot, it's just not standard NoSQL caching, right? You can store relational tables. That means you can create materialized views, continuous aggregation, and query that aggregation for your end service layer. I can process the data, so I don't have to push the data out of caching to a processing layer, then bring it back to caching for a serving layer. So I can be that consumption, like where the transactions are coming and the service layer for your applications. So your application is not talking to 4 different systems. It is talking to one, and your application is not gonna fire a query, pick up the data and process it. That's the typical architectures that most of the applications are built in, right? because the databases are slow or no SQL, you kind of build the logic into the app layer. Over here, your app calls, application can just send calls in a simple query, right? And the processing can happen on Volt, within Volt, and only the results are going through the network. That is also a reason where we are saying, while we manage end-to-end decisioning on Volt within 10 milliseconds, that 10 won't become 200 milliseconds on your network, because the data that is going out of Volt is just the result and very small data to travel through your network.
Thank you, Parth. Like
Yeah.
I said, so next question is from financial institution. So the question is, as we are regulated by SEBI, there are numbers of compliance which we need to comply while working with data and user data, etc. So are we comply with such regulators?
See, we are a solution that you can deploy within your secured environment, right? So first thing, we don't have access to your data. Neither we do anything on your data. So you bring it within your environment and you build it. That could be on cloud, on-prem, in your data center. And of course, within the database, there are certain capabilities that you can use to manage, segregate data and build security on top of data. Who accesses it, which data is masked, how do you store it? All of those things are doable.
Right. And in the past, just to add on top of it, in the past we have huge financial services, huge banks, and this type of financial services company using our product, and we have complied, tried to comply or help them comply to different PCI compliance, GDPR compliance, those kind of things, right? So all of that is possible.
Perfect. Thank you both. Next question is, how does Volt Active Data's in-memory architecture optimize data processing speed?
Right. So as I said, right, Volt is an in-memory transactional data store. And typically, when we talk about data speeds, in comparable to a traditional data product or a database product, when you try to transact, there are concepts like locking, latching. You want to, let's say, two concurrent transactions are trying to manipulate a particular data event in the database. You need to maintain certain level of isolation between them so that both of them do not concurrently try to update that, right? So ideally, what you do is take up a lock on that particular record and then do it in a isolated fashion, right? With Volt, the way how the data is distributed first is very different, right? We distribute the entire data on a per partition basis, basically sharded on a core level. So that gives the first access to let's say you want to do concurrent operations to do different, let's say, data events. Those can be done concurrently across two different partitions at the same time, right? So that is possible. And then we isolate all of these transactions in a strict serializable fashion. So we know that any request that is coming and for one manipulation of one particular data event, and the other event which wants to manipulate the same piece of data is actually serialized across that particular queue which we maintain internally, right? So that particular thing gives us a lot of edge compared to processing speed and optimization compared to the traditional data products.
Thank you, Viplav. So I'm taking two questions together. What data consistency and durability guarantee does Volt Active Data platform provides? First. Second, how much data can I store in Volt Active Data cluster?
Right. And there's a brilliant question. I think this question has been asked to us time and again. So I think in terms of guarantees that we talk about, imagine getting scalability guarantees that you would expect out of any NoSQL database, a similar scalability guarantees, but the consistency guarantees like a traditional database which is fully ACID compliant, 100% ACID guarantee, right? Atomicity, consistency, strict serializable isolation, and durability. I think the last question was around durability. So your primary data is in memory, and you can choose to configure the durability to disk based on what type of guarantees you want. You want synchronous durability or you want asynchronous durability. So that's how it's done in order to answer that question. And in terms of how much data we can store any amount of data as long as you think that the entire data can fit in memory, right? So we have customers who have about double-digit, terabytes of data being processed and kept inside Volt. Right?
Perfect. So I think, Biplab, you have answered this question, but I'm bringing it back again to you. How Volt involves in AI to help analytics in real time?
Right. So I think Fahad covered this question already. So
Right.
when you want to, depends upon what kind of AI. So if I talk about the traditional non-generative type AI, and you want to do real-time machine learning stuff, Volt helps you do it in a millisecond fashion, right? You can bring in your models, different kind of machine learning models, and deploy it on Volt. And while the events are coming in, you are basically acting on those particular events, taking a decision based on how the models have been trained, right? So that is one way of doing it. In terms of comparing it, or what Volt can enable in terms of generative AI, imagine Volt processing the data as soon as the data comes from the source, right? So that is where Volt helps. Now, once your data is processed, then you can throw it to any further vector data store and to generate the context and respond. So all of that can be done. In fact, RAG is an area where Volt is actively working, where you can utilize the capabilities of Volt in a generative AI design.
Perfect. Next, so I think we just have a couple of more questions. Next question in line is managing the complexity of large-scale cloud architecture and ensuring data security across network is always a challenge. How this has been addressed?
Right. Maybe Fahad, if you would want to take this up.
Right. See, that's why, like I said, Volt, we are a solution. You can use the solution and deploy it within your secure environment and secure framework. So we don't define those security frameworks. Right? It is up to the organization or the use case that you're doing, and you could always use Volt and kind of fine tune it for your security environment.
Yeah. And just to address that large scale cloud architectures, right? Volt is a cloud native product, right? Now, you want to deploy it with any hyperscalers, right? It can be just done with the click of a button, right? Depending upon how do you want to configure it and all of that. So we kind of utilize these kind of capabilities out of the box that's been provided by the product, and then help you enable at a large scale cloud designs, architectures, or deployments. And of course, as Fahad said, we cover the security part as well, in order to protect your in-motion data, or whether the data is at rest. We help you we help with features that enables to do these kind of operations.
Thank you, Fahad. Thank you, Biplab. I think we are.
There's one thing that I wanted to add, right? I think there was a question about is there a free version for testing? Yes, please reach out to me and Biplab. We can help you set up some sandbox and give you some licenses to evaluate and test the use cases that you think you are in mind. And as we close, I think Indravan is going to tell you how you can contact us, but please feel free to connect with me and Biplab for any of your use cases to discuss how we could actually effectively change low latency performance for your applications and enable you to kind of scale them to your future growth. Thanks, Biplab. Yeah, go ahead.
Perfect. Thank you, Fahad. Thank you, Biplab, for that. I was about to address that. So if you want to reach out to, if you have any question further, if you want to have any detail on our offerings, so there are two email IDs. I mean, like Fahad rightly said, you can reach out to Biplab and Fahad. So quickly, I'll just let you know their email ID. So you can see their names, Biplab Banerjee. So you can reach out to Biplab on his email ID, which is bbanerjee@voltactivedata.com. You can reach out to Mr. Fahad Khan on fkhan@voltactivedata.com. You can also see these mail IDs. We have responded some of the questions publicly, where you can see some of the email IDs which is already there. Fahad just responded to one of the questions. So you can see those, you can use those email IDs to reach out to Biplab, to reach out to Fahad, to reach out to me, or for that matter, even you can reach out to Caroline. So these are the 4 email IDs that you can reach out to.